What's the chance of your BFDI prediction being right? If I sent you back in time to watch only the first episode of BFDI and told you to try and predict the entire season, what would be your chance of guessing every single rejoin, debut and elimination in order all the way until the last episode of BFDI? How small is that number? Well, this is just textbook probability, right? Just a fun fact, if you will. Absolutely not! There is an absurd amount of possibilities, far more than you'd expect. So let's use a pencil and start. Actually, wait, hold your pencils. We need to agree on what counts as a correct prediction. There are multiple things that we can predict: eliminations, team swaps, rejoins, the number of episodes, etc. But we care about one thing only, and it's the order of all the eliminations, rejoins and debuts. If I gave you the 21 contestants from BFDI and told you to order them correctly, your chances are actually quite simple to calculate. It's 1 in 21 factorial. What is this exclamation mark, you might ask? This is a factorial. Here's how it works. Imagine you have 21, maybe 3 contestants, and the question is, in how many ways can I put them in an order? For the first contestant, we have 3 possibilities to choose from. Then, for the second, we have 2, and then a single one remains. In total, that's 3 times 2 times 1. Now, what if we want to know the order for 4 contestants? That's right, there are 4 possibilities for the first contestant, and for each next one we play the same game of arranging 3 other ones. So we end up with 4 times 3 times 2 times 1. This is called a factorial, and for higher numbers like 21, it's much easier to simplify the possibilities to 21 factorial. So, if only one order can be correct, the chance of the prediction being correct is 1 in 21 factorial. That's also 1 over 21, 1 over 20, 1 over 19 and onwards. So if we multiply that, we get 1 over 21 factorial. And that's 1 in 51 quintillion, 90 quadrillion, 942 trillion, 171 billion, 709,440,000. So that's all right. That's the answer. It's small. You can go home now. There's nothing I forgot to address. Okay, we have a problem. As you probably noticed, we have a few issues, like David being a debut and there being a few rejoins. Based on what we agreed on, we have to include those in our prediction, and it sucks. Why? Because it complicates our math. Let's say our time traveler watched a bunch of other object shows and knows that there's a chance of an elimination, rejoin or debut. From the time traveler's perspective, there are 3 options to choose from, and exactly one of them is correct. So that's a 1 in 3 chance for each of these. And let's not forget that you also have to predict whether the finale happens at the final 2 or 3. That itself is fine, but for each of these, there's also a correct contestant to choose. And if you only watch the first episode of BFDI, how would you even know about who will have a chance of debuting? There is none. There are way too many potential characters that can join, and you wouldn't know about any of them. Okay, let's slow down a bit. We're doing this no matter how difficult it gets. Let's start. Finally. First, your chance of getting the first elimination right is actually higher, since both 1A and 1B came out on the same day. You already know the first contestants up for eliminations, and your chances of guessing that Flower gets out first are 1 in 10. Then, the second episode. You know that a debut or rejoin can happen, but for now it doesn't matter. We're trying to solve the probability of the correct path, not all the possibilities. So, for the next eliminations, your chances of guessing are 1 in 19, and then 1 in 18, and onwards to 1 in 15 before the first rejoin. We multiply each of these by 1 over 3 for guessing these are eliminations. To simplify, we're going to write this all as this. Wait, why 14 factorial over 19 factorial? It's a simplification. You know how 2 over 4 can be simplified to 1 over 2? By dividing both by 2? Well, if we divide by 14 factorial, we get 1 over 19 times 18 times 17 times 16 times 15. Okay, get it? I hope so. Don't worry, it gets much worse from here on out. There are 6 contestants that can rejoin, so we have a 1 in 6 chance of guessing that Blocky rejoins. We multiply that by 1 over 3, and once again, as this is another event, this time a rejoin. What's next? More eliminations. We get 1 over 15 again, because the number of contestants went up by 1. And if we multiply that by the next few chances of guessing it's an elimination, we can simplify it to 10 factorial over 15 factorial. Same reason as this guy. Current chances? Panju rejoins, that's another 1 over 3 and 1 over 10. And 4 more eliminations. So let's add the power of 4 to the 1 over 3 and multiply by 7 factorial over 11 factorial. The full equation as of now is this. And now for the... wait, no, the debut. I knew this would be problematic from the start. If sent back in time to the release of BFDI, how would you even know who would have a chance of debuting? There's no potential list we get at the start of the season, all of the recommended characters appear after the first episode, so is this whole equation a waste of time? No. Although there is no correct solution, we can still try to look at our options and choose the one that seems the most fair. Here's 3 that I thought of. Number 1. We could just assume that we somehow know that one of these 30 objects will join. Number 2. We could know the amount of all the recommended characters by BFDI 17, which is pretty high. Number 3. We could say that the character that debuts doesn't matter at all and make the chance of it just 1. All of these options are assumptions, meaning all of these are equally fair or unfair, but after asking n people where n belongs to all natural numbers, I decided on number 3. Let's say who debuts doesn't matter. They're like a blank slate that could be replaced by any character. If you prefer the other options, you can multiply the final number we get. Okay, so right now, including the debut, the chances are this equation. Now, we're almost at the end. We add 3 new eliminations, Flower rejoins, that's another event, and the pool of contestants was 15, so it's 1 over 15. And we add a few more eliminations just before the finale. Oh, now here's the part where you use the pencil. Do you remember how many ways we can order the final 3? It's 6. We also need to multiply it by 1 over 2, assuming that we know the finale is between 3 or 2 contestants. 6 times 2, 12. So that gives us a 1 in 12 chance. We add that onto our final equation. So after multiplying it all, we get 1 in 14 undecillion, 693 decillion, 446 nonillion, 496 octillion, 339 septillion, 113 sextillion, 219 quintillion, 366 quadrillion, 130 trillion, 114 billion, 560 million. God! These chances are so low that you have a higher chance of picking up the single grain of sand on Earth that I called Gary, finding the sun from all the stars in the observable universe, finding one exact atom chosen in advance among all the water in 60 Olympic swimming pools, and around the same as your chances of finding a girlfriend. So, if you somehow predicted any other season, call me because I want your lottery numbers. BFDI has many more mysteries left to solve, like what's the deal with your light and how does it solve one of the biggest mysteries in BFDI? If you want an answer to that, watch this video next. And thank you for watching the video. I know it took a while to make, but I hope you enjoyed it.